Welcome, space fans and science explorers. Prepare for a journey from your living room all the way to the edge of black holes and the beginning of the universe. Today, we unravel the story of gravity, the silent, invisible force that shapes every moment, every planet, every galaxy, and even the fate of time itself. Gravity isn't just a law of nature. It's the reason the universe has structure and why you are alive to wonder about it. When gravity, the unseen sculptor, stop for a second and look around. Why does your coffee stay in the cup? Why do the moon and earth dance in the sky? Why did the solar system form at all? Gravity is the answer, gluing together every atom, pebble, planet, and star. Without it, there would be no stars, no planets, no galaxies, no up or down, and no you. Gravity is always attractive. There's no such thing as anti-gravity in real physics, despite what sci-fi claims. It acts between every single particle with mass, everywhere, forever. The four fundamental forces, and why gravity stands alone. There are four fundamental forces in the universe: gravity, electromagnetic force, strong nuclear force, weak nuclear force. But gravity is unique. It's incredibly weak. A tiny fridge magnet can lift a paperclip against all of Earth's gravity. And yet it controls the largest structures in the universe: galaxies, clusters, even the shape and fate of the entire cosmos. Its reach is infinite, and it's always attractive, never repulsive. A brief history of gravity. From legends to relativity, ancient times, myths and first ideas. For millennia, people wondered why apples fell, but the moon didn't. Aristotle thought objects fell because they sought their natural place. Many cultures had creation stories where gods held the sky in place. Galileo, the rebel thinker in the 17th century, Galileo Galilei showed, famously from the Leaning Tower of Pisa, that all objects fall at the same rate in a vacuum, no matter their mass dot. This shattered centuries-old dogma and laid the foundation for modern science. Newton, the universal law. Isaac Newton, inspired by that falling apple, published Principia in 1687 and declared, "Every object in the universe attracts every other with a force proportional to their masses, and inversely proportional to the square of the distance between them." Newton's gravity unified earthly and cosmic motion. It explained why planets orbit, why comets return, why tides rise and fall. Suddenly, the universe was a place of law and order, not arbitrary chaos. Einstein, a revolution in space and time. By the early 20th century, Newton's law couldn't explain certain phenomena, like Mercury's wobbly orbit. Enter Albert Einstein and the general theory of relativity, 1915. Gravity is not a force, but a curvature of space-time caused by mass and energy. Mass tells space how to curve, and space tells mass how to move. Imagine a trampoline. Place a bowling ball, the sun on it, and marbles, planets, spiral around the dent. That's gravity, not as a force, but as geometry. Modern gravity, quantum conundrums. Einstein's theory, works perfectly for planets and galaxies. But at atomic scales, gravity refuses to fit with quantum mechanics. The search for a theory of everything that unifies gravity with the other forces is the greatest challenge in modern physics. How does gravity really work? Einstein's relativity. Gravity is not a force, but the effect of curved spacetime. Objects follow the straightest path, a geodesic, in curved space. Everyday effects, dropping your phone, gravity. Ocean tides, the moon's gravity tugs at Earth's oceans. Satellites? They fall perpetually around the Earth, creating orbit. Gravity's range, from everyday life to cosmic extremes on Earth. Acceleration due to gravity, 9.81 ms2. Every second, a falling object gains about 10 meters per second in speed. Jumping on the moon's gravity is just 1/6 of Earth's, so you could jump 6 times higher. Jupiter. Gravity is over 5x stronger than on Earth. Astronauts would barely stand. On a neutron star. Neutron stars pack the mass of our sun into a city-sized sphere. Gravity so extreme that a teaspoonful of neutron star weighs 1 billion tons. Standing on the surface, you'd be instantly crushed. Black holes, the ultimate gravity monsters. The escape velocity is faster than light. Nothing, not even light, can escape the event horizon. At the core, a singularity, where space and time cease to exist as we know them. Gravity and time, the strangest connection. Einstein's greatest insight. Gravity bends not just space, but also time. The stronger the gravity, the slower time flows. Clocks at sea level run ever so slightly slower than those on mountaintops. In GPS satellites, time runs faster, less gravity. If not corrected, your phone's maps would be off by kilometers every day. At black holes, near a black hole, time nearly stops relative to distant observers. The movie Interstellar famously showed this with 1 hour near a black hole equaling 7 years on Earth. A scientifically accurate idea. How does gravity shape the universe? Gravity causes clouds of gas and dust to collapse into stars and planets. Stars cluster into galaxies, and galaxies into clusters and superclusters. Gravity sculpts the cosmic web, the largest structures in existence. Birth of a star. Without gravity, the universe would be a thin soup of particles forever drifting apart. Gravity brings matter together, sparks nuclear fusion, creates heat and light and thus life. Dark matter and dark energy. Gravity's greatest mysteries. Dark matter galaxies spin so fast that visible matter isn't enough to hold them together. An unseen dark matter provides the missing gravitational glue. We can't see it, touch it, or detect it directly, but its gravity shapes galaxies and clusters. Dark energy, even more mysterious, the universe's expansion is speeding up. Dark energy seems to push everything apart, working against gravity on cosmic scales. Its nature? Completely unknown, it could decide the fate of the cosmos. Gravity's paradox. Weakest but most influential, gravity is vastly weaker than the electromagnetic or nuclear forces. A tiny fridge magnet beats all of Earth's gravity. But gravity dominates because it always attracts, never repels. Its reach is infinite. It acts on mass, and everything has mass.gravity in everyday life and technology sport. Every jump, fall, catch, and bounce is a dance with gravity. Engineering, bridges, skyscrapers, airplanes, and rockets, all are designed to withstand or exploit gravity. Medicine. Your bones and muscles are shaped by gravity. Astronauts lose bone and muscle in zero gravity. Satellites and space. All satellites orbit because they are in constant free fall around the Earth. The International Space Station doesn't float because there's no gravity. It floats because it's in free fall. Timekeeping. The world's most accurate clocks, atomic clocks, are now so precise that they detect gravity's effects from a few centimeters difference in height. Experiments that changed our understanding. Cavendish experiment, 1797. Henry Cavendish measured the force between lead spheres and calculated the mass of the Earth. Eötvös experiment. Laurent Eötvös proved that gravitational and inertial mass are equal. Foundation for Einstein's theories. LIGO and gravitational waves, 2015. For the first time, we detected ripples in spacetime from colliding black holes. Opened a whole new way of observing the universe, hearing rather than just seeing. Frontiers. Quantum gravity and the graviton. Gravity refuses to play nicely with quantum mechanics. Physicists dream of discovering the graviton, a hypothetical quantum particle of gravity. String theory, loop quantum gravity, and other bold theories are racing to explain how gravity really works on the smallest scales. Gravity in human culture and imagination, myths and legends. From ancient stories of gods holding the sky to modern superhero comics. Movies and sci-fi, Interstellar, Gravity, Star Wars, and hundreds of sci-fi tales imagine warp drives, anti-gravity, or impossible gravity traps. Art and architecture. From pyramids to skyscrapers, humans have challenged gravity for millennia. Open questions. Gravity's greatest mysteries. What exactly is gravity? Force, geometry, or something else entirely? Is the graviton real? Why is gravity so much weaker than other forces? Can we shield, reverse, or manipulate gravity? What will happen to gravity in a dying universe trillions of years from now? Could we ever create artificial gravity in space habitats? Philosophical reflections. Without gravity, there would be no order, only chaos. Gravity links every atom in your body to every galaxy in the cosmos. It reminds us, the universe is both stunningly simple and impossibly complex. Gravity is the silent architect of reality, the hidden hand behind every falling apple, every orbiting planet, every living creature. It is at once the simplest thing in the world, why things fall, and the deepest mystery, connecting us to the birth and fate of the universe. What fascinates you most about gravity? Would you dare visit a black hole or bounce on the moon? Do you think we'll ever fully understand gravity? Or will a new Einstein rewrite the rules again? Leave a comment, smash that like and subscribe, and join us for more mind-blowing journeys through the cosmos.